A lot of students tend to think that natural erosion is quick and happens on a large scale due to human activity or a cataclysmic event. Not so. We know that erosion usually takes place over hundreds or even millions of years. Welcome to Split Second Science. Today, we'll explore how large masses of ice, called glaciers, can change the Earth's surface by slowly moving, causing weathering, erosion, and deposition to the landform. We will focus on these guiding questions. Which landforms are created by glaciers or ice erosion? How do glaciers change the Earth's surface? Our lesson is connected to TEKS SCI 5.7b, where students recognize how landforms, such as deltas, canyons, and sand dunes, are the result of changes to Earth's surface by wind, water, and ice. To support student learning, we'll implement HISD's elementary science best practices, 3D to 2D transfer, and Realia. 3D to 2D transfer enables students to take what they've learned in a concrete, hands-on lesson and transfer that knowledge onto paper or into a journal. Realia allows a teacher to use concrete objects to convey meaning so students can master a concept. During the lesson, teachers will facilitate learning experiences to build conceptual understanding, provide opportunities for conceptual understanding to be transferred from concrete to abstract, assess students' understanding at multiple points throughout the lesson, guide students to connect vocabulary and concepts to real life via the use of concrete models, and ensure mastery of core academic content. Students will participate fully in learning experiences and seek conceptual understanding, transfer conceptual understanding from hands-on to paper and pencil assignments, make connections between the concrete objects and abstract concepts, use concrete objects to connect academic and content language, and reflect on their own understanding throughout the lesson. Now let's watch our teacher simulate how ice can cause erosion to Earth's surface and cause landforms to change.
For this investigation, you'll need the following materials: sand, topsoil or dirt if you have some, gravel or small pieces of rock. You'll need an aluminum pan, a bottle of water, a spatula, and I'll be using a styrofoam cup. Before you start the investigation, pour some water into your styrofoam cup. Place this cup inside the freezer for about 4 hours. This will later become our glacier model. To begin creating your landform, start with pouring a small amount of water at the base of your pan. Next, pour sand to fill the bottom of your pan. Next, take your topsoil and lightly sprinkle some over the top of your sand. Next, do the same thing with your gravel. Continue to add layers of sand, soil, and gravel until your pan is about halfway full. Be sure to add water to make the dirt and gravel stick together. Once your landform is about halfway full in the pan, take your spatula to make it flat. Once you are complete, your landform should look something similar to this. After your ice is completely frozen, remove the cup from the freezer and take the ice from the styrofoam cup. Now we have our glacier model. When you're ready to start, begin by taking your glacier and going back and forth down the middle of your landform. As you're doing this, ask students if they can notice any sediment starting to break down. Ask students if they notice any sediment beginning to move. As we're moving the glacier back and forth with our model, what do we notice that's happening to the sediment? As we pick up our glacier, what do we notice that's collecting on the ice? What do we notice to our landform? Ask students these guiding questions during the investigation. Continue to carve out the middle of your landform and continue to ask students the guiding questions. Once you're done, have students make observations and collect those observations in their notebooks. Also, lead a discussion on why there's dirt or sediment around the ice. Lead a discussion on what happened to the landform. Students need to understand that glaciers can cause weathering and erosion by breaking down sediment and causing it to move throughout the landform. Students also need to understand that glaciers create U-shaped valleys in certain landforms. This is a good explanation or a good demonstration on how our glacier created a U-shaped valley. 3D to 2D transfer is the purposeful movement within a lesson from concrete to abstract. At the conclusion of this lesson, we can provide students with an exit ticket to assess their learning.
Teachers must also ensure that students are recording data in their science journals or interactive notebooks. Students need to draw conclusions based on their findings and enter those in their interactive notebooks. This is a great way for teachers to evaluate students' understanding and provide authentic feedback. Here's a quick recap of what we just covered. We reviewed the HISD Science Best Practices, 3D to 2D transfer, and realia. We demonstrated how ice can cause sediment to break down and move, resulting in changes to the Earth's surface. Thanks for watching, and be sure to check out the other segments of Split Second Science.